pala tayo sa ano yun, sa warehouse. So papapyawan lang po natin mga loads, no? So karagdagang kaalaman lang po sa mga ka-maintenance natin dyan at mga ka-electrician na hindi pa nakakaranas na magtrabaho po sa katulad dito sa mga ganito, no? Mga electric resources natin, no? Sa electricity, sa wind farm, so mga turbina. So papapyawan lang po natin, no? Konting kaalaman lang po. Ito po yung tinatawag na, yan po yung tinatawag na transformer, no? Na meron tayong, we have three components of three component parts of wind turbine. So papakilala ko lang po, no? Yan po yung tinatawag na transformer. So yan pong tatlong tong nakikita nyo ay yan po yung ano, magkakasama po sa loob ng nacelle. Yung nacelle na tinatawag po ay yung katulad po ng yung tinatawag na nacelle, at panoorin po natin saglit tong video na to ng instructor po natin.
Top of the nacelle, we simply have a hole through which we climb. And the nacelle in this case is a vaguely tapered tube. At the back we have the wind sensors, which give us speed and direction and allow the turbine to face into the wind and to change the angle of the blades. The nacelle itself is just a fiberglass tube. At the front we have a similar fiberglass cowl protecting the hub, which is a steel casting on which we have bolted our three blades, and the blades can turn or pitch so that the angle they form with the wind can be varied. Out of the back of the hub we have a shaft which leads into the gearbox, then a high-speed shaft through a brake into a generator, and that generator then supplies the electrical power, as I say, at about 690 volts all the way back down the tower to the base. And right at the back we have a cooling fan, as we're generating 500,000 watts of energy inside the nacelle. Some of that is wasted as heat, and without an efficient cooling system there is the potential for the turbine to catch fire. Now the layout of a larger turbine is broadly similar, but some of the components are in different places. So let's start by looking at the tower section of a typical 2 megawatt turbine. Where we place the high voltage transformers in multi-megawatt turbines is a lot more variable. Quite frankly, we have a lot more room, so we can decide it. They can be in the nacelle, they can be at the base of the tower, they can be on platform 1 in the basement, they can be outside in a hut. In this example, the transformer's at the top, so when we go into our door, the one thing we'll not find is a transformer. We do have the high voltage switches, this case on platform 2, but on the entrance platform we have that usual control cabinet and a lift, a little green box. And that lift will take 2 people to the top of the tower, or nearly to the top, without them having to climb the single, very, very long ladder. Almost all large turbines will just have a single run of ladder for the majority of the run up the tower. It will have a wire or a rail system, fall arrest device fitted to it, but it is still a long slog up the ladder, which is one of the reasons why service lifts are so important. And again, the tower's in sections so that it can be delivered around the country without demolishing villages. Sometimes, if we're running a long distance and we haven't got room for a proper platform, we can put a half moon in place. No fall protection on the platform, but we assume you would keep your lanyards connected at this point because it's quite a long way down. The cable again breaks free from its mounting and hangs in the centre of the tower for the last 10-20 metres or so that it can rotate as the nacelle yaws into the wind. And the lift eventually runs out of space. Remember, the tower is getting narrower and narrower as we get to the top. So the lift tends to park itself about half a platform from the top, and we have a normal ladder which then leads to the yaw platform, and then it starts looking very much like the smaller turbine did. We have a yaw ring bolted to the underside of the nacelle, joining it to the top of the tower. A series of disc brakes run around that yaw ring to lock it in position when the wind isn't changing direction. And when it is, we have a series of either electric or hydraulic motors that rotate the entire mechanism around on the top of the tower. The layout of a multi-megawatt nacelle is again more variable than for a smaller version. We always have to have a generator But we may not have to have a transformer. In a few cases, such as the famous Enercon egg-shaped nacelle, we don't even need a gearbox. They're direct drive. We just have a shaft linking to a motor, and then lots of extremely complicated electronics to condition that power for connection to the grid. But in most cases, we need the same as we needed in the small turbine. Gearbox, generator, possibly a transformer, all in a fiberglass box. And in our example, we're looking at a typical design used by a number of manufacturers where we have a nacelle that's 3 meters high, 2.5 meters wide, 7 or 8 meters long. It's a fiberglass box about the size of a site hut. As before, we have our wind sensors on the roof as far away as possible from the dirty air cast off by the blades as they spin round. This design is just a fiberglass box with a flat roof. We access the roof through a couple of skylights. Some designs are like before, big cylinder with 2 opening doors. Some have an entire roof section which opens, rather like an old camper van. If we take the skin off the box, inside we have the same kind of components we had before. They're just bigger, and there's a little bit more room, so they're laid out a bit differently. The only additional component up here is those 3 green cylinders at the back. That's our high voltage transformer, which used to be at the base of the tower. Now we've removed a lot of the control systems and the hydraulic systems that would just clutter up the pretty picture. We've added in a bloke for scale, but most of the big components are still here. If we look at the very front of the nacelle, we have a couple of bearings which support the main shaft, which is a hollow tube, 50, 60, 70 centimeters in diameter. It's hollow so that we can get electrical cables in through this main shaft into the hub to drive all the control systems inside the hub. And we have a couple of pins on the first bearing that lock the main rotor in position if we need to access the hub. It's a safety feature. If you're in there and it starts rotating, it gets scary. So our main shaft drives our gearbox, which is mounted centrally because it's often the heaviest component. Out of the back comes a high-speed shaft, as before. That's where the braking system is. High-speed shaft then drives the generator, which is usually oil-filled. The generator then supplies 690 volts, in this case into our transformer, which is sitting right next to it. That high-voltage signal then passes through the switchgear in the cabinet, down the dropper cable, straight down to the bottom of the tower, through those switches on platform 2 and off to the substation. And that, as an overview, is pretty much all there is to it. The only thing left to talk about are the blades, obviously, which actually do the work. We still have 3 of them. They still pitch, in other words, they twist on themselves to line up with the wind. And you access the hub through the gap between this fiberglass cowl and the cast hub. It's a bit of a wriggle, but you wriggle through, usually feet first, crawl through the hole in the middle of the hub, and inside the hub we'll find the control electronics, the pumps, the motors and the batteries to control the pitch of each blade, rotating it on its own bearing to set the optimum angle for the wind. If we turn the blades through 90 degrees so they're edge on to the wind, there's no net turning force. It's a process called feathering, and the turbine will stop. Obviously there is a vast amount more going on inside a turbine, lots of wiring and control systems and lights and sensors and fire extinguishers, etc. But that is basically it, the general overview of most turbines that you find on wind farms today. Designs for the future will be significantly different, but at the moment it's a windmill with a stick.